In this video, we're going to go over some basic fundamentals in shader and material creation. We're going to go over how to use math and basic color to create various different image and rendering effects for our materials inside of Unreal Engine. We'll go over what the essentials are of what an image is and how we use that data in conjunction with mathematical functions to actually create the various effects that we can use in many different material effects. So with that being said, let's get started. So before we can get into the Unreal Engine portion of this lesson, I wanted to kind of quickly go over some very simple basic fundamentals in computer graphics. So first, let's start off with the values of black and white, because in shaders, we don't use black and white as, their images and colors as they are. We actually also use them for the data that they represent. That goes down to, they are basically bits. Bits are just very single bits of information. In particular, the color black represents the number 0, and the color white represents the number 1. We can use those in many different ways in shaders as well. We can use them to toggle things. We can use them to simply mask things, whether what areas that are in white get masked off and what areas in black are not masked off. We can use those values. Next, we have 8-bit color. So the basic 2 bits that we have, the 0 and the 1, are a binary. But the thing is that there's no way to just use those ones. We don't have enough information to really see the small little gradations or gradients of color in between. So what we end up doing is we don't just use the 2 bits, the 0 and the 1. We actually use 2 to the power of 8, thus giving us many more bits of value. That's not just the black and white, but also the grayscale values that transition from black to white. So 2 to the power 8 equals 256 values, or in a better way of putting it, 0 to 255, because we use 0 as the start, not 1. So if you ever looked at RGB values or HSV values inside of Photoshop or any other type of image editing format, the 0 to 255 value is the fact that we're using 8 bits of value with 2 bits, the 0 and the 1 kind of in particular. What these do is we can use different basic maths between these 2 values to create the small gradations of black, 25%, 50%, 75% gray, and then of course white. But this just gets us grayscale value. Essentially no color, no nothing, just gray. How do we actually get color? Well, that's where RGB color comes in. With the 256 values, we have of course the great range of grayscale, but to get color, we actually have to use 3 8-bit color slots, or channels as we would like to use as reference. These 3 different channels, the red, green, and blue channels, are all just grayscale values from 0 to 255. And when you hit 255 in any one of those channels, we'll define red in that channel, or green if it's in the green channel, or blue if it's in the blue channel. If we want to use kind of mixes of colors, say we want to use things like magenta, yellow, and cyan, we just need to mix 2 of those channels. Red and green make yellow, blue and red make magenta, and blue and green make cyan. Now, for those of you who are traditionally trained with color theory with basic paints in the real world, it's a little different because primary color is not red, green, blue. It's actually red, Y, blue, because you can mix any of those colors together to get the other tertiary colors, like red and yellow making orange, red and blue making violet, and green and yellow making, or sorry, not green and yellow, but yellow and blue making green. So it's a little different when we use digital color theory. So digital color theory revolves around red, green, and blue being the primary colors. With using kind of shader computations, we're going to actually also have a 4th color channel that we can actually use for many different things. This 4th color channel, which we refer to as alpha channel, is actually not a visible color, but represents a visibility or invisibility or opacity value. Typically when we look at this, or when we see how it's rendered in the color slider or the color picker inside the palettes, usually you'll see it as white from the value of 255, and then when you start to go down to 0, as in no opacity, no alpha, it comes with this kind of checkerboard pattern. And that's how computer graphics and image processing programs use their definition of defining when something is transparent or invisible, essentially. So alpha channel is just a fourth color channel. With this value and those three other values being all 8 bits, they define for RGB being 24 bits of color. And with the fourth color channel, we essentially now have another 8-bit color channel to use. With the R, G, and B values, we get 3 8-bit channels, which that becomes a 24-bit image. That's what most typical images that we see, things like JPEG, PNG, Targa, what have you, they're all 24-bit images. When we give a alpha channel, the image doesn't stay as a 24-bit image, it now becomes a 32-bit image because it's now 4 8-bit channels. With using RGB, the 3 channels alone, with, if you mock up the 256 times 256 times 256 values, you get at least about 16 million color interpretations that we can use. So there's about 16 million different color combinations that we can use with these 3 channels alone just to get whatever color we necessarily need for visible color. Now, with the understanding of what these colors actually are and how they kind of reference with the numerical value of images, we can actually use these numerical values with mathematical nodes, things that we're typically used to: multiply, subtract, add, and divide. And we can actually use those with these color values to actually create different image adjustments or image changes. We can actually make modifications in the materials themselves with just this. So here inside of the Unreal Engine material editor, let's go over kind of what we had just talked about. So we just talked about what a color is essentially in the process, as it's numbers that correlates to values. Those values are put into channels, and depending on what values are in those channels, you'll see the colors essentially. So let's start off with how do you even define colors and stuff inside of the material editor. So inside of here, we have this little menu. If you hit right click inside the graph, you'll get this little pop-up menu. This pop-up menu, you can search up any node you might want to use inside of the material editor. The ones you're looking for are constant vectors. So there's 4 of them that we want to use. There's constant, then there's vector 2, 3, and 4. Each vector is essentially an additional channel that's added on over time. So with the first vector, we have this one. This one just gives us a simple value. So if I were to plug this guy in, you can see when I have it at 0, it of course renders on this little material ball here in this viewport, it's 0 or black. So if I set this to white or 1, you can see right here. If you set it to say like 0.5, it gives us half light, it's a little darker. But if we actually look with this little arrow right here, this arrow will show us a little preview of what the value typically will look like. And this might be a little confusing because it's showing red. The reason why it's showing red is in the logic that is the material editor, because the red channel is the first grayscale color channel that's actually used in the whole processes. There's R, G, and B. It renders as red as a preview that this is the first grayscale value. So as a grayscale value alone, it's technically the red channel that's being used. But yeah, don't be surprised. It's still going to render white, as you can see right here. Then of course we have our constant 2 vector. So the constant 2 vector, as you can see, we now have not just this one single value, but we actually have a red and green slot right here. These slots can actually pull the individual value of the red or green values. So if I go in here and I set, say, both values to 1, if you see 1 inside of the red, or white in the red gives us red, white in the green gives us a green, but when we have them both, it's yellow, because that's the combination of digital red and digital green. And if I do, of course, like 0.5, I'll make it darker and stuff. But one thing you'll notice is that it says X right here and Y. When we use these values, Unreal Engine likes to correlate kind of similar bits of information. So as we move forward, we go from like 1 value to then 2, then to 3 with R, G, and B, we can actually correlate RGB with other three pairs of values. So the one we see right here is X and Y. The reason why we have X and Y is because X and Y is a part of things like natural direction or world position that has X, Y, and then there's a third value, Z. We actually use that for movement and motion, rotation, scale, all that kind of stuff. So we can actually use this for something like that. There's also another thing that we can actually use a little later on, but we'll get to that just a little bit into the demo. But as you can see, we can go in here, and of course, as we plug in these values, of course, it's still going to show white when we actually log it in like this. But realistically speaking, the white is just, get white of the red or white of the green. But when we put them together, we get yellow. Next is our constant vector 3. And with this, we actually now have full color. So when we plug this in, if I double click on this now, I can choose any color I might want, like this nice orange color. So I can go through there by double clicking on this, or I can even use the values here. And this allows me to actually, have a full renderable visible color essentially. The last one is kind of what we talked about. It's a vector 4. So this one is a little different because instead of just having the one slot right here, it actually has two. Because with the vector 4, we now have RGB color plus an alpha channel. So if we go in here, you can actually even see a little bit with this little box. This is our kind of preview value. As you can see, because our alpha and everything else is set to 0, it's got this checkerboard. Again, in computer graphics and image processing programs, they always will use checkerboards to kind of render when there's no alpha, as in it's not a opaque material, but it's see-through. But if I go into here and set this value up to 1, you can see now it's just showing full red, or show full black. And then if I choose any other color, as you can see, they're both kind of separate. You can change whatever color you want, but the color does not change the alpha, because the alpha is kind of separate from the visible RGB color. So I can hit OK, and I can either grab the RGB here, or I can grab the RGB alpha if I need to use all 4 values for whatever reason. So this has all those, and then I can of course have my red, green, blue, and then alpha as well. So you can actually use separate channels, use all 4, or even just use the 3 RGB values. But these are our 4 vectors. If you need to quickly add a vector into your material graph, it's very simple. And this is kind of very simple for all basic nodes. If you hit one of the letters or numbers on your keyboard, like say 1, and hit the left mouse button, it will pop in a new node. So that's with 1, 2, 3, and 4. So just pressing one of those numbers or pressing holding that number with a left click will get you this. So you can use any of these guys at any time. And what's cool is, you can use these values just alone just to create a simple material. I can grab this, plug them in as my base color, and I can grab a scalar and plug this guy in as one of my different values, say my roughness. So I'll change him, set him to 0.14, and I'll change this guy and make sure that he's set to 0 because I don't want metallic. But this gives me a nice simple material. So you can use values. It's cheaper to use the values if you need to. You don't necessarily have to always use a fully textured image for your albedo, roughness, or normal or anything like that. You can just use simple values, and that can help solve a lot of performance issues. But with all that, this is the essentials at least of the colors and numerical values inside of the material editor. Now let's go over the mathematics. So we have a couple simple mathematics. We have, of course, add, we have multiply, we have divide, and we have subtract. So each and every one of these is exactly the same mathematical operation, but each one is going to be act a little bit differently depending on what you do or apply into the materials. So let's move these guys down a little bit, and let's start to bring in some images that I can use to edit. So let's go into here, content, grab my textures, and I'll grab, these 3. So So I'm going to use these images, these textures, with these nodes to actually show you what you can actually do with it. Because, of course, the easiest thing is you can take one of these guys and you can use them as math. So you can plug in any one of these vectors, or you can actually even use these values as well. You don't have to use another vector to plug into this. Like say if I use 0 and 1, so 0 plus 1. So A slot refers to the left number in the operation, B is the right. So whatever you put in here will change whatever aspect you're using. So if I do 1 plus 1, I can go in here, and of course, because technically 1 plus 1 is 2, I don't technically see a difference, because you can only go as far as white. You can't go beyond white or the number 1. So because of that, we can't really see a major difference essentially. But what we can do is, if you ever need to kind of quickly see a numerical value with whatever you're plugging in, like say you need to see how all this is working, you can quickly just go into here and type in debug, and you can do debug scalar values. Now, I would say there's one thing you need to change, which is the amount of digits. So I usually use 3 values. So I plug this in, I can plug in this value, plug that into my result, and you'll get a number. And that number is 2. 1 plus 1 is 2. So I do 1 plus 1, say with 5, or 1 plus 5 is 6. And then there's like a dot for your integer, and then you have 0 and 0. So you can see the values at work. So debug scalar values allows you to actually see the numbers. You don't have to worry too much about it. But now we can actually go and to start using these operations with the colors and with the textures. So first, let's start off with an addition. So we'll start off with this checkerboard. So I'll plug this checkerboard in here. And so one thing to note is with add and multiply versus divide and subtract, add and multiply are the type of values that you can choose whatever in the A slot or the B slot, and the reaction is going to be the same. You can swap them around, there's going to be no issues. Divide and subtract, you actually have to be conscientious of what you and where you plug them into, because it'll give you different results. So let's start off with addition. And how it will work is if I go in here and I type in a value, so I start off with 0. So we have this checkerboard texture right here. And if I change this guy, so let's start him off with say 0.5, see what happens. So what happened right here is, and if I even go into this little add, you'll see that it went from this white and black checkerboard to this white and gray value. Now you're probably wondering what happened exactly. How does this work? So we're adding 0.5 not just to one spot, but to all areas of our checkerboard. And what's happening is, say this, we go back to the whole white is 1 and the black is 0. So if we add the 0.5 to the white areas, that's now 1.5. Because again, 1.5 is above 1, we can't see the difference because it just shows white. But 0 or black plus 0.5 is 0.5. So that gives us this gray value. So if I hit 1 now, boom, now we have full white. So add, what it does is it just adds and kind of lightens your image starting from the darkest point. And it doesn't add necessarily like white. It kind of have more of like an adds whiter and whiter kind of fade to your thing because it's using white as the color. You can also actually subtract colors too. Like if I want to subtract, say, let's subtract the color red and let's see what happens. Or sorry, not subtract, but like let's hit add on here. So let's plug this in. Oh, it looks like we have a bit of an issue. We have something with arithmetic. So this is sometimes an error that might pop up. So what it means by you're having an issue with arithmetic is the floats here. So floats is another term for the vectors. So I'm using this guy right here, this RGB is a vector 3 values because it's 3 color channels. Down here, I grabbed the RGBA value. That's 4 values. So a value of 3 and a value of 4, they don't really work together. They're not copacetic, but we need to probably grab this. So if you actually hold shift, you can grab an input like this and grab it and plug it in like there. And ta-da! So as you can see, I've now added the red to the black area and it works. Of course, again, white doesn't do anything, but if I want to, I can even go a step further and grab the yellow color too, and boom, now I have white and yellow. So add just adds additional things. It add, you know, from you start from a 0 to a white or 0 to 1 value, it will always lighten whatever's there. It won't really darken or choose to darken anything. What if we do multiply now? How will this work? So let's grab these two values and we'll plug them in. And now, as we can see, something's a little different. So in this instance, it's a little different. Multiply will actually darken in some instances. It doesn't seem like it, but it does. So what's happening is the black that we see here is because, again, it's 0. So if you think about it in a multiplication sense, 0 times whatever value, say 1, 2, 9, or even just say, let's say yellow is a number. 0 times that will just be 0. So whatever's black will stay black in the color. But if it's white, like say these checkerboards here, that's 1. 1 times whatever value will be that value. 1 times 0.5, 1 times 2, 1 times red or green or yellow. It shows that. So what we're seeing right here is the multiplication sense of it, but another way you can think about it is just like with add doing a bit of a lighting type of value, will it slowly lighten the darkest areas? Multiply tints. We use this term for it because it's tinting a kind of neutral value like a gray or a white, and it just adds that color right on top essentially. So that goes to show you that it allows us to, you know, use something like this. It's really, really useful. So that's what these guys do. And again, you can interchange them. You can swap spots. Like you can put this guy into the B slot and the other one to the A slot, and that's about it. It's only when we start to get into things like subtract and divide is where things get a little different. So if I grab this guy and I subtract this yellow color from here, let's see what happens. So it looks like it's now kind of inverted a little bit. So what's essentially going on here is when we grab this yellow value, because this yellow is white in two values, and it's adding, it's like it's subtracting from the front. So let's say the yellow is our first value, and then this is our second value. So what's essentially happening is that whatever value, if it's lower than the value from before, it makes it darker. So see how it's black right here? So this is 1. Say these guys are 1, but they're 1 in the two values, like they're not in all values. So like if I even just say swap this guy to even blue, you'll see it's now been kind of inverted essentially. What's going on is 1 minus whatever kind of creates an inversion. So there's this, there's also even using this value as well too. What this does is that it will invert the value. So 1 minus 0 is of course 1. So 0 being black will now become 1. So that's why it's white. The black area, which is say this left corner, when it's 1 minus 1, well, 1 minus 1 is 0. So it makes it easy like that. But if say I have one of these guys, like say if I go back to just red, so 0 and 0, and I plug him in like so, well, something's happened a little bit. Let me grab the texture again, like this and this. So as you can see here, again, it's doing the opposite. So it's subtracting white, the 1 from these values. Like, so this technically is 1, but it's not in the exact value. So like technically it counts it as white because it's still white in a value, but it just makes it go black because, you know, white 1 minus 1, even if it's 1 in one color channel, it's still going to subtract it. Whereas in the black value, black, which is 0, minus, you know, 1, actually sorry, this is 1 minus 0. So 1 minus 0 in the red, or red minus 0 just shows red. So that's why the black areas only show red, whereas the white areas kind of invert and become black. So it's about this similar thing essentially. What we saw before, which was this, where it's the checkerboard and you get this cyan color, it's the opposite, or it's not opposite, but it's similar. But essentially what's going on is that this red value because it's a fragment of full white, because again, white is all white in the red, green, and blue channels. So if it's 1 minus red, well, what are the other two channels now? Green and blue. And what are the color combinations of green and blue? Cyan. So this allows you to kind of cut in the fragment and leave what's left. So you can actually have this color right here. But flipping it the other way around creates an inversion, because 1 minus anything will always be an inversion. If I do even just like you said, this 1 value right here, he's just white because he's just rendering the whole white color, whereas this guy's only showing the whole red color. So he's going to invert and flip to the other values. You can even do something similar. So just like this, if I grab the checkerboard here and 1 minus it, you can see that he inverts. There's also another node called 1 minus. And this 1 minus, again, what it does is it adds a subtraction value, or it inverts a value. So say if I grab this guy and plug him in, watch what happens. The exact same. Because if you see here, 1 minus x, the x is whatever we plug into. That's the integer. So 1 minus 1 is black, so that's why the left side's black. 1 minus 0 is 1, so that's why it inverts. So that goes to show you that you can use something like that. It's the same also thing if you do even like a half value, like say, let's say 0.25. So if I do 1 minus 0.25, what's gonna happen is I'm gonna get a brighter value. What happens is that when you do 1 minus 0.25, you get 0.75. So 0.75 kind of is the inverse operation of this. A better example is this guy. So if I have this texture right here, which is my roughness, as you can see, I have this roughness value right here. So you can see where some areas are rough, some areas are shiny. Watch what happens when I plug that into a 1 minus, and then I plug that 1 minus into my roughness. It inverts it. So the areas that were rough are now shiny, the areas that were shiny are now rough. So that's kind of what allows you to create this kind of cool inversing. So you ever need kind of flip-flop a value, you can do so with a 1 minus essentially. So that's subtraction. The last one is divide, and divide is kind of similar, if not same, in a sense where add will brighten, subtract will darken, multiply will darken, divide will brighten. So they're kind of the inverse of each other. Like if I grab this guy and I do this, he does kind of what he's supposed to, but he adds cyan in between values, so he's kind of brightening in some aspect. But if I change it all to white, or supposed to be white, yes. Looks like he's creating a little odd value in here. Let's see. Base color. Oh, yeah, no, he still looks the same. So it's just like a weird visual thing. So divide kind of does a similar thing, but you have to change the values. So like say if I grab this, so if I start off with another, vector 0, if I do this, technically what's supposed to happen is anything divided by 0 typically is 0 for the most part, so it actually would be causing an error, but it can't compute the 0 part, so it's fine. Actually, let's try the opposite. Here we go, that's why it's 0 now. Whereas like 1 divided by 0, which if you do 1 divided by 0, I believe it does the inverse operation of it, so it becomes a multiply, but it multiplies and just leaves it as exactly, it's like times it by 1 essentially. But if I do say 0.5, again, nothing's really happened here, but let's try this again. See, so now with 0.5 being in the front of it, it asks for half of the values. But again, 0.5 of a darker than 0.5 value, like say black, it just makes it into a high value. So 0 times 0.5 becomes times it by 1. 0.5 divided by 1, or 1 divided by 0.5 is still 0.5. 0 divided by 0.5 becomes 0 times, I'm getting my math all messed up, but basically it becomes, instead of 0.5, it's like the fraction turns into 1. So instead of being 1/2, it becomes 2 over 1, which becomes 1 essentially. So it becomes essentially that value. So it becomes a whole value number. If you do, say, 0.25, again, I think the values are typically kind of the same, just the values become a little darker. If I do the full 1 divided anything will always be that 1 value. So 0 divided by 1 becomes 1 over 1, which becomes just the 1 value. And then 1 divided by 1 is 1. So divide doesn't really give us that much of a difference. Divide's only useful besides some simple math values, like if you want to make something brighter with just lower numbers, you totally can do that. But divide and add are about the same. They always will brighten, even with like these values. Subtract, multiply will always darken. But these are not the only reasons why you would want to use these values. You can also use math and numbers with textures, not just for the whole tinting and brightening stuff, but you can actually use them for another aspect that we use a lot. So let me grab these textures and plug in this simple wood material that I've made. So ambient occlusion goes here, roughness here, normal right here, and base color. And now we have our little varnished looking wood. What we can use these guys for with these divide, multiply, subtract, all that stuff, we use it with a texture coordinate node. Now a texture coordinate node, what it does is it allows us to access and modify the UVs of the asset that we're working with. So if I grab this guy and plug him into here, and here, and here, so far nothing's happened because we haven't really made any modifications yet, but that's where we have to go in and start to use some math. So let's start off with some simple multiply value. Scooch these guys out of the way a little bit, and let's start off with multiply. So multiply, I'm gonna grab the one number we've not used yet, which is these guys here. So I had already talked about, these guys have X and Y, they have R and G. What else can they be used for? Well, there's another pair of values that work well with this, and we've already have just said it in this texture coordinate, U and V. Now, UVs essentially are just you unfolding and unwrapping a three-dimensional value onto a flat planar space. UV space is a little different, so it's calculated just a tiny bit differently. But we can use these math values with these numerical values to actually modify them where we need to. So if I plug in this value here and this value in here, and then I hold shift to grab all these inputs in here. Now, nothing's happened yet, but that's because they're all set to 1. Remember, 1 times anything is that thing. So what if I do 1 times 2? Well, it doubles it. And in this case, by doubling, we've now tiled him more. And what's cool is this tile, because you have 2 values here, you can independently tile them separately. So they don't have to be exactly the same. So you can tile this guy 5 times versus 4 times or something, or 2 times by 4 times. So almost doubling in one aspect ratio. So multiplying allows you to do tiling, essentially scaling your textures, so you don't have to actually go into the UVs of the 3D mesh itself and actually modify them. So that's one aspect. Now let's grab the add node, which if you ever need to quickly add in a math node, just like how I talked about if you do 1, left click, 2, 3, and 4, you can do the same thing with math. So M for multiply does multiply, A for add, D for divide, but unfortunately, S does not give you a subtract. So you still have to actually search up subtract. But let's grab this add node, let me delete the old one here, and let's start off with this. So we'll grab another one of these guys. So let's grab another one of these guys and plug them in. And let me set these to 0 first, because again, just like in math, you want to start off with just a flat value. 0 plus anything will always be that thing. Just like how 1 times that thing will be that thing. So let's do this. And as we can see, nothing's really happened yet so far. But let's start to add in a value, like say 0.5 here. Oh, we might have noticed something happening like right here. Have you noticed, hopefully? What's going on is I'm moving these guys. I'm moving the textures at the very least. And by moving, I mean I'm offsetting. So by using an add node, it allows you to, from 0 to 1, move in either the X or Y directions of your UVs. 0 meaning that there's no movement, 1 meaning that technically it's back to the original origin, but it just means that between 0 and 1, you can slowly move from one side to the other of your UV space. So you can actually make a small little adjustment, like say if you don't want to see a certain repetitive value, you can offset and make things look a little bit differently. So that's what's good with coordinates and stuff. Subtract, that's a little different. So subtract, you don't really want to add anything in here, but say you, actually let me grab one of these, this guy right here. So let me grab him. Oh, sorry, let me change the arithmetic back. But let me grab this texture and replace him. So we're gonna plug this guy in here. As you can see, here's my little coordinate node. Let's see what happens when I plug in my subtract into him. Well, it looks like he should change, but I don't think he's been swapping where he needs to swap. But let's see if I can get him to show up. Yeah, typically what's supposed to happen is he's supposed to invert, but I guess when you just have a simple value like this, he just kind of flips left and right or upside down. If I grab another one of these images, typically one that doesn't have like everything looks good on left, right, or center. If I type in logo, we have these Unreal Engine logos built into the Unreal Engine graph. If I grab this and I plug him here, you'll see I have this tiling texture like this. If I grab this subtract node like so, he actually will invert him up, or at least from the up perspective. So he inverts him, I think, on both sides. I believe if I go into here, one here, one here. So yeah, even with both values, he just inverts upside down no matter the case. So that's like the one little thing you can do with subtraction. It just kind of creates a small little inversion, kind of inverts the opposite way. But that's how you can use subtract a little bit with this. I mostly try to use subtract mostly for an inversion of like the black and white value, but it's here nor there. Now, the last thing is, using a texture. Like say you have this like checkerboard texture that's, tiled a bunch of times like this. And you're like, I need to, maybe I have this texture like this already, and I want to tile him a little bit differently. Like maybe I don't want to have to tile him further and further and further. Like maybe I need to shrink him down somehow. Well, that's where divide comes in. Because if I go in here and plug a divide in to this texture, he actually divides, making him smaller. So divide him by 1, he stays the same. Divided by 2, he shrinks. 3, 4, 5, things like that. So typically in coordinates like say, landscape coordinates, or even sometimes how you set up things for like using world position as your value of tiling, you can use a divide node to help with your tiling so you don't use and have such a very large number to begin with. Or sometimes you have like a multiply, but it's like multiplied by like 0.01 or something. You can use one of these values a bit. So from there, you can even do like say 0.25, and using lower numbers will actually tile more. So divide just does the inverse of what multiply does. By using lower numbers, you can tile more, whereas you can use higher numbers and multiply to tile more. I like the multiply aspect better because it feels in my head cohesive. Bigger number, bigger amount of tiling. Divide's kind of the opposite of it. But for the most part, using these basic math nodes, you can create a very simple shader relatively by just making some simple adjustments. Things like grabbing your base color and applying a multiply with a vector 3, allowing you to tint whatever image that you're using. Like say this wood always has different colors to them, or stains. So you can go in here and you can stain them. Like I can make him, magenta, but it's not exactly a science on this one. You have to use like a grayscale texture. Like say if maybe instead of using this texture, I might use this texture instead. So by using a grayscale or white texture, or close to white, you'll have more of a natural cyan color. But because there was a red brown already with the cyan, it made more of a green color. So if you want to use tinting really well, you have to use a grayscale texture to begin with, allowing you to be able to tint this with a more effective color. So whatever you see here will become that color. So this allows you to tint and create some really cool and almost in some ways natural kind of color. It just depends on how you want to approach your staining for your wood. But that's one aspect. You can use multiplies with your roughness as well. So you can adjust this with a value so you can either brighten or darken your roughness. So like this, he's very, very shiny now by using just a simple value like that. I can even do like say 0.2. So he's still fairly shiny, catches the light, but maybe I don't like how shiny he is. So I might use 2 instead. And 2 makes him more rougher. So using these mathematical values with these numerical values, you can actually make these adjustments so that you can take your values and make them appear differently. That's one of the best things about Unreal Engine, is that you don't have to make new textures again and again and again. You just need to make sure you set your textures up like this, and then you can actually go about creating some really cool and really interesting effects with just some simple math nodes. That's what's great about this. But for the most part, that is math and numerical values with color inside of Unreal Engine, and how we can actually create cool and interesting shaders as like a nice simple effect. Next, in some of the upcoming videos, we'll go over how to set up our textures, because for some, you might have set up some textures here inside of Unreal Engine and you might have had issues with your roughness or your height or ambient occlusion not appearing how it's supposed to. And there's only a couple different things you need to change just to make sure that they look right. We'll go over that. We'll go over other subjects like texel density. We'll go over how to do things like channel packing and what are some effective ways of channel packing, and how we can use different ways to help with optimization. So as I move forward with a lot of these videos, I definitely want to try and make sure I go over a lot more of these fundamentals. I'll intersperse some of the fundamental and introductory things that you might need to know for math and for material shaders, and then also intersperse some more intermediate and even advanced shader courses. So if there's anything you guys are very interested in or very curious more about, please let me know in the comments. I'll definitely try and make sure I make a video on the topic. So yeah, thank you all so much.